In this video, we are going to practice our ionic nomenclature or naming ionic compounds. A few quick things to refresh our memory. How do you know the charge of a transition metal if you're given a name? So you're going to have your cation or the metal name. Then you'll have a Roman numeral in parentheses, and then you'll have your anion. The Roman numeral is equal to the charge on the cation. So that is how you know the charge of your transition metal if you're given a name. If you're given a formula, so as an example, let's make this Fe2O3, you need to use what you know and work your way backwards. So we know that oxygen is a -2 charge. This tells me that there's 3 of them, so that's a total of -6. So if we want to think of this as a picture, here's 1 oxygen, here's 2 oxygens, here's 3 oxygens, and it tells me I only have 2 irons to balance that out. So I need to split this in half with my 2 irons, and that means I'm going to need 3 pluses on each. If you want to think about it mathematically, I've got some charge that I don't know times 2 that has to equal a +6, so that we've got neutral. That makes this charge a +3. So that's how you would figure out charge if you're given the formula. So now if we get to naming, you're going to name the cation simply by using the element's name from the periodic table. Nothing changes. Then the anion, it depends what the anion is. If it's a polyatomic like it is here, we've got different atoms making up our ion. We're going to look at the polyatomic ion table and pull it straight from that table. So Ba is barium, straight from the periodic table. CO3 is carbonate. So that one is barium carbonate. Next I've got lithium. PO4 from the polyatomic table is phosphate. Notice I don't do anything with number of ions. So there's 3 lithiums, but that's not part of the name. The reason for that is if you're given the name, you can always figure out the formula because we know charges. So the name kind of tells you only as much as you need to know. Going the other direction, name to formula. Here I have sodium, which I know is Na, group 1, +1 charge. Sulfide, remember IDE means I'm using the element from the periodic table, which is just S. S is in group 6, so it's a -2. So put those together. We're going to need 2 sodiums for every 1 sulfide ion. Calcium chlorate. Calcium is a 2+. Chlorate, anytime you see 8 or ite, make sure you're looking at your polyatomic ion table here. Chlorate is Cl(O)3 with a -1 charge. So our formula will be CaClO3, and I need 2 of them. Here we have iron, which is a transition metal. When you have transition metals, you need that Roman numeral to indicate charge. We'll come back to that. PO4 is phosphate. And remember that Roman numeral is charge. It's not how many you have, so I'm not putting a 3 in there. I need to work backwards to figure out the charge. This is one where uncrossing is a good way to do it. Phosphate's -3, which we can figure out from the table. That means the 2 comes up and makes iron a +2 charge. So the Roman numeral in the name is 2, iron 2 phosphate. Gold 3, so that's going to be Au with a +3 charge. Chloride, so that's Cl with a -1 charge. So we're going to have AuCl3.